Right now, we want to know what is the function of water in our concrete mix. This is important ingredient. Without water, all your ingredient will be in terms of dust and not bind together. So, water is used. The terms is hydration. Hydration means the ability to absorb water. The first thing, the function of water is to enable the chemical reaction for your concrete mix, and then your cement will act as paste so it can bind all the things together. You have your fine aggregate and your coarse aggregate, and sometimes you might add mixture. So cement and aggregates with water will create a paste that can bind everything together and form concrete mix. Okay, other function of water is to dampen the aggregates from absorbing additional water. And then it's also to lubricate the mixture of gravel, sand and cement. This is for placing. And the last part is to make sure your concrete mix workable and easy to place. So what else for water? You need to add water is just enough so that your cement or your concrete mix will function accordingly. If too much, it can give a bad effect to your concrete mix. If too little, it also cause not suitable reaction to your concrete mix. So let's see what happen if the water is not enough. If not enough, it is not enough for hydration. Thus, the cement is too dry, and of course, it will difficult to place. So, if the water is too much, this is most likely to happen. If you don't mix according to mix design, you just use your own guts. Therefore, sometimes too much water will mix your concrete mix not in the proportion that we need. So if too much water, cement weaken and thus less strength and durability. And if there is a lot of water, more void as the water evaporates, and of course it will result in less density. And also it can form a chalk powder layer on the surface of concrete mix, thus prevent proper bonding of the next layer of concrete and create a plane of weaknesses. Meaning that if you have your layer here, and of course you need to put another layer for your concrete mix on the top of your concrete mix, because of a lot of water in your concrete mix design, therefore it will form chalk powder layer here. So this available chalk powder layer towards the end will create a plane of weaknesses. So next, cement grout leak out from work, meaning that this can carry away cement, leaving sand and aggregates. Therefore, it will cause honeycomb in concrete. Let's see the picture. What is the meaning by honeycomb? Okay, this is the concrete mix for column. You have place it in formwork and then you erect the formwork, but suddenly you find this effect from your work. So this is the effect of honeycomb. What happened in this situation is what we know as the the cement has leaving the sand and aggregate. So you can see clearly the coarse aggregates here and also fine aggregate. This is another example for honeycomb. This is a severe because you are seeing a very large opening here, and this is another example of honeycomb. So what are the properties of suitable water for our concrete mix? of course the water must be pure. If you can get a pure water, no oil, we don't want acid, we don't want alkali, and we don't want organic impurities in the mix. And of course it must be in the form of alkali, so the pH value is not less than 6, so it must be higher than 6. And then it must be no iron content, no vegetable matter, or any substance. And the last part is we don't want salt in the water, because it can reduce the strength of your concrete, and because salt water also not recommended because of presence of harmful salts. Not salt is good, not all salt is good. Some salt will give adverse effect to your concrete mix. So this table suggests if there is the presence of water in your concrete mix, what are the percentage of reduction in terms of strength. So if 0.5% salt of SO4, the strength will be reduced for 4%. If you have 5% salt in water in terms of NaCl salt, therefore it will reduce to 30% of concrete strength. So we don't want any salts. Even a very small amount of salt will give adverse effect to your concrete mix. So what are the impurities in water? We have salt in seawater. This is the natural occurrence. We know that seawater is salty. And of course, we do have industrial wastewater. This is from factory or from your domestic household. And of course, from silt or suspended particles. So for salt in seawater, of course we know that seawater is not suitable to mix our concrete. This is because of the salt is the agent of corrosion. So if you are constructing reinforced concrete, it will corrode the reinforcement inside your concrete. And also salt will reduce the ultimate strength of concrete. So the strength will be reduced, usually 10 to 20% in strength of concrete at 28 days. It's very bad, you know. And then of course seawater will cause dampness and surface efflorescence. Okay, what is surface efflorescence? It means the migration of salt to the surface of porous material where it form a coating. So let's say this is your brick here, and due to efflorescence it will migrate to the surface. So you will see a white powder to the surface here. That is the cause of efflorescence. For industrial water from industry, it might contain acid or alkali. A typical sewage contains roughly 400 ppm of organic matter. After treatment, it still have about 20 ppm or less. And the last one is silt or suspended particle. This is about 200 ppm of suspended clay or fine rock particle in mixing water. And also we don't want algae, because algae can cause reduction in strength of concrete, and also weakness of bond between aggregate and cement paste, and large quantity of air entrained in the concrete, thus lowering the strength of the concrete. So besides of salt, we also aware about sugar, and if sugar contained in the water is also not advisable. So less 0.05%, generally no adverse effect, but there is more than 0.25% of sugar, rapid setting may result in a marked reduction in 28 days strength. So this is all the suggestion if there are sugar contained in your water, in your concrete mix. And The limit of permissible impurities, if organic, it is about 0.02% of solid by weight of water. If inorganic, is 0.3 of solid by weight of water. This is sulfate, about 0.05. For alkali chlorides, is about 0.2 for plain concrete and 0.1 for reinforced concrete. And the suitability of water, we do have standard for guidance, and the standard is from BS 3148, and for Malaysian standard it is from MS 7.3. So the common types of testing water for concrete mix are initial setting time test, and then also the compressive strength test. Suitability of water for making concrete can be categorized into two. Number one is treated water. Whatever water you get from whatever source, you treat it first. And then second is water from natural sources. This one is more likely to have natural and alkali types of water for our concrete mix. So that is all for water inside the concrete mix, and this is the additional chapter for ingredient for concrete. Okay, thank you.